Hey, welcome back to your online notes for AP Stats, talking about categorical variables, and once we've gathered the data on those variables, what we want to do with that data. So last night we talked about displaying them either in a pie chart or bar graph, and you had some practice in your homework on making bar graphs. And it is important, as we've seen. Sometimes graphs can be misleading, and sometimes they're purposefully misleading, and sometimes on accident. But so we do want to be kind of careful how we make them. Make sure we're labeling everything. Again, seems kind of elementary, but it does at least need to be said. So there you go. So once we have this data, what do we want to do with it? What's next in our data analysis? We want to try to add some numerical measurements to these variables. Quantitative variables, it becomes very easy to do. Categorical, there's not a whole lot we can do. There are a couple of things we can do. The first thing that we'll typically try to do with categorical variables is try to figure out if there's some sort of relationship between two of them. Look at the distribution of one of them is interesting enough. Kind of gives you an overall sense of what category your population or your sample tends to fall into, I guess. But a lot of times we'll try to put two of them together and try to come up with some sort of relationship. We'll definitely, again, examine the variables on their own, but then we'll put them together. And we'll put them together in what's called a two-way table. A two-way table describes two categorical variables. The organizing counts according to a row variable and a column variable. So our rows will be one particular variable and the values that that variable will take. Our columns will be the other one. And we'll actually use the counts. We won't worry about doing percentages here. The percentages come in just a couple of seconds. Does it matter which variable is columns and which one's rows? It doesn't. You can flip them around. It doesn't make any difference whatsoever. There's an example on page 12 that talks about a survey that was done with young adults, and they even give an age range. So hopefully you're in the habit of following along in your book as we go through the notes. I reference the book quite often, but it was a survey of 4,826 randomly selected young adults aged 19 to 25. And they asked, what do you think are the chances you'll have much more than a middle-class income at age 30? And so this table gives us those results. So we've got two categorical variables here, right? Well, what are they? What are the two categorical variables? So in a two-way table, we need to be able to pick that out, right? Now, let's go back. Okay. Well, first off, we've got rows going this way, right? And these are all the values of the variable of opinion, right? So our two variables are opinion, or opinions, and then the ones going across for the columns, obviously, is gender. Okay, so we've broken the information down by those two variables. There may be other variables we could look at, and we would pair those up accordingly, but for right now, these are what we're looking at. And so, being able to pull information out of this table is kind of important. How many young adults were surveyed total? Well, we've got a total column and a total row here that breaks down each value of each variable, but obviously our total for the entire survey is 4,826. Hopefully we were able to find that pretty easily. So just kind of taking a look at the two-way table, making sure we understand how to read it. So we'll take we'll give a survey, right, and then we'll gather the information, and then we can put some of those categorical variables in two-way tables. And to what purpose? Well, that's where we're trying to figure out if there's some sort of association. There's a couple of ways we can do that. One, we can create what's called a marginal distribution. Okay? And a marginal distribution is is where we'll take a two-way table and we'll break down one of the variables, right? So in a two-way, so it's the marginal distribution in a two-way table of counts is the distribution of values of that particular variable among all individuals described by the table. So in other words, we're going to break down one of the variables, and we'll talk about how to do that in just a second. But a couple of things, because the table will be in counts, we want to convert those over to percents in terms of a relative frequency. Just because percentages are a little bit more informative, it's easier to compare the different values that way instead of just using the look at the raw counts. But the other thing is sometimes your groups are going to be different sizes. And so if we convert things to percents, then it doesn't, it doesn't matter as much if our groups are different sizes, if the values have different totals and things of that nature. So we just want to make sure we're using relative frequencies or percents. And I want to keep referring to, this keeps jumping ahead on me, but I want to keep referring to these percents are also relative frequencies, and that's because you'll keep hearing that term sort of thrown around, and that's terrible, but you get the point. Okay. Now, to examine a marginal distribution, we're going to use the data in the table to calculate the marginal distribution of the row or the columns, and so we're going to use the totals. So we'll either use the total of the column or the total of the rows, and again we'll make sense of this in a second if it's not yet, and then we'll try to come up with some way to graph or display that marginal distribution. Okay. Let's see, anything else I want to say about that? Okay. Now, just again, it's just a way to sort of break down the information that's in the two-way table. So to take a look at a marginal distribution, we're here. So we're back to our opinion with young adults about whether they're going to get rich or not by the time they're 30, or be rich or not by the time they're 30. If we want to examine the marginal distribution of chance of getting rich, right? So that's the deal. The marginal distribution of chance of getting rich. Then we're only going to concern ourselves with that particular variable. So these guys. So then I want to use these total numbers here, right? I'm just trying to break down that particular variable. I'm not really concerned about gender right now, okay? And that's easy enough. So we'll sort of pull those values out into a separate table, right? And then start filling in, oops. And I'll start filling in with you. So here we want to talk about almost no chance, and I'll abbreviate some chance, but probably not. And then we got 50-50 chance, and then we got a good chance, and then we have almost certain. And we want to know how those different values break down amongst the total 4,826. So it just becomes a matter of creating these percents. Okay, which gets us about 4%. And then we go 712 out of 4826, right? Which if we divide that out, and I feel pretty confident that you guys can probably handle that. And then we go, what, 1416 divided by 7826, which gets us about 29.3%. And then for the good chance, there's 1421, which gets us about 29.4%. And then 1,083 out of, this is supposed to be 48, not 78, but you knew that. right, which gets us about 22.4%. Okay? So that's our marginal distribution. Now we can always go the other way, right? We can also do a marginal distribution of gender, right? At which point we would just simply divide each gender number by the total and find out the percentage of males and females that we had in the survey too, which could be helpful. But anyway, we do it for the opinion, and once we have our table, again, it's always nice to kind of come up with some sort of graphical display to help show the data that you're looking at. So here's our bar graph. And so you take a look at this bar graph, you start asking yourself, all right, well, yes, I've got the percentages over here, and it might be easier to look at these if there are only a few of them. As we get a lot more, then this graph becomes helpful. It looks like our taller bars are over on this side, which kind of gets us into, you know, a decent chance, that, you know, 50-50 chance and above, a good chance or almost certain there's more respondents in that area than the almost none or some chance. So, you know, the bulk of these young adults kind of feel like they're going to be rich by the time they're 30, which is good. I think everybody thinks that in some form. Unfortunately, it doesn't always work out, but anyway, that's a whole different story. So there's your marginal distribution. Okay. All right. Let's see. The check your understanding on page 14 wants you to do the marginal distribution on gender and then make a graph to display the marginal distribution, describe what you see. The describe what you see is kind of important there, so I'll leave that up for you to do. And then maybe we can talk about it real quick in class tomorrow. So take a couple seconds if you want to stop the video and do that, that's fine. My guess is we're pretty good there, but we'll definitely check it tomorrow when we get to class. All right. Okay, I'm going to go ahead and move on though. And so while marginal distributions are good, it allows us to take a two-way table and pull out one of the variables and break it down and kind of see what's going on with it. It doesn't really give us much information about the relationship I was talking about before. If I want to try to come up with some sort of relationship between these two variables, then I need to come up with some other way of doing that. And what allows us to try to create that is what's called a conditional distribution. And so now what we're going to do is we're going to take our counts in our table and we're going to break those down into percentages, but we're going to do it under a certain condition. We're going to do it for one of the variables. And conditional distributions can sometimes be tough to figure out which way through the table we're going to go, whether it's the rows or the columns, and so we're going to have some conversation about that. Okay? But anyway, the conditional distribution is what we use to try to create this relationship, right? So we need to try to figure out, again, like I said, if we're interested in the rows or the columns, we've got to select the row or column of interest first, and then use the data to calculate the distribution in percentages of the rows or the columns. And then what we'll do from there is make a display, again, so we can kind of get an overall feel of what the data is trying to tell us. And that display can come in the form of two things. We can do what's called a side-by-side bar graph, and I'll show you what that looks like in a second, or what's something called a segmented bar graph, which these things I think are very, very tough to read. Can sometimes be very hard to get any information out of. I don't particularly like them. I like the side-by-side bar graphs a whole lot more. It's even been suggested that segmented bar graphs aren't even part of the AP topic outline, but they did show up on the AP exam last year. So, you know, we got to talk about them and maybe even create them so that we're not surprised when AP exam rolls around. So, so let's take a look at a conditional distribution, right? So back to our opinion and young adults and getting rich and the conversation that we always enjoy having, right? So if we want to calculate the conditional distribution of opinion among gender, right, is usually how that will say. Now, this says among males, okay? Generally, it'll say something like, calculate the conditional distribution of opinion among gender. And so then that means that we're going to, for each gender, create the distribution of opinion, right? So that means rows or columns. Which one are we looking at here? Are we going to go across the rows or down the columns? In other words, do I want to break this down, this down, this down, or do I want to go this way, up and down, right? That's the question. Well, because we're doing it for the males, because we're doing it based on gender, we're doing the distribution of opinion for the gender. We want to break down each gender, so that suggests to us using the columns, okay? So I want to go down the male column and find out the percentages of males that have each different opinion, right? And I guess we need to write these in as well. And so once we've figured out which way to go, obviously the work becomes fairly mundane, fairly easy. So male, it means I'm going to take 98 and divide it by, any guesses? Okay, right, the 2459. That's what I'm dividing it by, right? That's my total of males. I don't want to divide it by the 4826. If I do that, then I'm taking a look at the percentage of males that believe almost no chance, right? And that's not what I want. I just want to break down each opinion for each gender. So another way to look at this is we can sort of cover up what we don't want, right? So once I decided I'm going down columns, I am only interested in this column. So I would sort of cover this up and cover this up and only focus on this guy right here, okay? And just worry about that distribution. And so I'm going to use the 2459, which is the total number of males we've got, right? And that's about 4%. And then same on down the line, right? 286 by 2459, which is about 11.6%. And then the 720 by 2459, and then the 758 by 2459, and then the 597 by 2459, and then we get all of these percentages. And again, I feel pretty comfortable that you can punch buttons in a calculator. Nothing too fancy here. Okay, so there's your conditional distribution of opinion for the males, right? And then we can put that into a bar graph, right? And I don't think you can see this bar graph in your slide. That's okay. I don't think, or maybe you can. But anyway, at any rate, again, we've made a couple of bar graphs. My guess is you could make this bar graph. So we've got our 5 different opinions, and the blue bars here are what we have for the males. Now, the next question here is examine the relationship between gender and opinion, right? Well, if we're going to do that, then I need the conditional distribution for both males and females. So we would need to go back and create that distribution for the females. And of course, didn't have that. And so I'll write down the first couple. If you want to fill in the rest just for your own completeness, that's completely fine, but I don't want to waste your time here. But we've got, see, for the females, we've got 96 out of, what are we going to divide it by? The 2367, right? Again, since I want to do the conditional distribution for the females now, I'm only worried about this first column. And so just making sure that we get the right numbers in the right place, right? And then you can go through and calculate these different percentages. What you should come up with as you do these is 4.1, 18%. This should be 29.4. This should be 28. And this should be 20.5. So make sure that you can get there. Okay? When we have those, now if I want to try to see a relationship between gender and opinion, then I'll put the distribution for females in the same bar graph with the males. So here's your side-by-side bar graph. Called that because your bars are side-by-side for each of the opinions. If you do that, you want to make sure you create a key here. Let us know which bars are females, which ones are males. But you can take a look at this, right? And what do you see, right? Well, I'll give you a second to look at that. What do you see? Well, as we get into the good chance to almost certain chance of being rich, look at the difference here, right? There's a higher percentage of males that feel that way than females. And if you sort of scroll down the line to the other side here, it's vice versa, which would make sense, right? So apparently females don't have as bright an outlook for their future as far as being rich goes, which, you know, is interesting. Why is that? That would be the next question, and then something that you can maybe further study on down the road, okay? But that's your conditional distribution. Now, I think I took out of here, yeah, I did, the segmented bar graph. And so let's take a quick look at that. Okay, and so what you're going to do is you're going to create a bar, a single bar for all 5 of these opinions, but then it's going to be segmented. It's going to have your different percentages located in that. And so it would look something like this. And this is on page 17 in your book, right? This is a segmented bar graph. And apparently, again, we need a key. The first part are the females, and the top part of the males. And so, again, you can take a look. And again, I just don't get as much information out of this, right? You look at this, and you start to see that, more females seem to think that, some chance, almost none right here, right? Those are taller than the other 3 bars, so females tend to not think as highly of their chances of being rich. And then to compare the males, you can kind of, it's sort of a, almost a complement kind of a deal where if the bars are higher here, then obviously they're going to be shorter here because we can only have 100% total out of each bar. Okay, that's the segmented bar graph. Sometimes these things are kind of tough, but I want to show them to you, and they pop up in the book every so often. Okay. All right. Now, check your understanding on page 17. Ask you to do a different kind of conditional distribution. Work that one out. See what you come up with. We'll compare that in class as well. I would still do a side-by-side bar graph and see if that makes any more sense as opposed to a segmented bar graph. And then see if doing a conditional distribution that way makes any more sense. Sorry for the glitch there. Obviously had to cut my notes off for a second as you heard the bell in the background. But anyway, and what I mean by makes any more sense is, again, which way, rows or columns, do we need to do our conditional distribution? And that kind of comes from a place where you have to decide, if we're trying to find an association or a relationship here, you have to kind of decide which way makes more sense to look at, which conditional distribution and for which variable makes the most sense. And one of the things that we're going to talk about and that we have to ask ourselves is, okay, which of our 2 categorical variables is going to influence the other, right? And we've already talked about explanatory and response variables, and so if you can try to figure out which categorical variable makes more sense to be the explanatory versus the response, then it can help you figure out which way you want to go. Do I want to break down the rows or do I want to break down the columns? And we'll talk more about that in class tomorrow as well. Okay. Last thing I want to talk about real quick, and something that we need to get into a format as we approach statistical problems. Is we've gone through chapter 4 and haven't really had to experience this yet, but when we sit down and we start trying to work out stats problems, especially as they become more complicated and there's more steps involved and there are more things that we have to keep in mind and conditions that we're going to have to check and all of that kind of stuff. This book outlines what it calls the 4-step process. And I think it's pretty good in terms of how you want to approach these statistics problems and to make sure that you get all of the information in each problem that you need. And so they'll show this icon, and I'll pull one up and show one to you in just a second. But anytime you see this 4-step icon, then the intention of that problem is for you to go through these 4 steps. And so the first step is going to be to state, what's the question that you're trying to answer, right? And we'll actually form it in the phrase of a question. And typically it's right there in the problem, it's right there in the setup. And so we're basically restating some of what the problem's asking, but anyway, it's important that we understand what it is that we're trying to find out. The next step is going to be to plan it out, right? How are we going to go about answering the question? What's the best way of answering that question? What techniques do we need to do? What calculations do we need to show? And those kind of things. Are there conditions that we want to make sure are true before we go do anything? And again, we'll add to that plan part as we develop more strategies. And then we'll actually go do the problem, right? Once we decide what how we're going to answer the question, we'll go do the things we need to answer the question, make graphs, do the calculations and all that kind of stuff. And then once we're done with that, we're going to conclude, right? And you want to give a practical conclusion in the setting of the real world problem. Now that's really important, in the setting of the real world problem. And what we mean by that is context. You always want to make conclusions. You always want to make your observations in context, right? I don't want to just give a generic definition of, and we talked about this in class too, of replication. I want to talk about how replication helps in this particular setting, what we're trying to be leery of. Statistically significant. I don't want to just give a generic definition of statistically significant. I want to do so. I want to explain why these particular studies' results are statistically significant. And so we always want to do this in context. And so this is going to be step 1, this is going to be step 2, this is going to be step 3, this is going to be step 4. And we'll very physically write these steps out, state, plan, do, conclude. Okay? At least for now. At some point, it'll make sense to sort of drop this format, but what we're trying to do is sort of develop a statistical approach to solving problems and just trying to make sure that we get everything in to these, the work that we need to show and all that kind of stuff. So as we go through, I'll keep referring to this and we'll keep discussing this and realizing what it is that we need to keep doing, okay? And so that's it. At this the end of section 1.1, and so we'll get into the next section, which is all about quantitative data and all the things that we can do with quantitative data. There's quite a bit more. We'll talk about how to do dot plots, stem plots, histograms, how to display our quantitative variables. Okay? Enjoy your night. We've got some homework that's out there that you'll be working on in class, and we'll see you guys tomorrow.